It's good to be with you all today. Thanks so much for Natalia for moderating the session and assisting us along when I make a few mistakes along the way, I'm sure. But welcome all. Again, my thanks to Karen Harris for the opportunity to be with you today to talk about science content, incorporation, engagement through a nascent collaborative experience of students. I think this is a very important topic. I asked her to register under the wake-up call because there's some things here that I think we forget over time. I've been in academia for probably about 30 years. That doesn't mean too much other than I'm just an old man. But you learn things as you go. And I think that's the beauty of learning and teaching. If you do it right, you should always be learning along with your students. So with that, I'd like us to start in the following fashion with an activity, a good way to begin with a classroom. And what I'd like you to do is using the chat, I'd like you to use one word, only one word, to describe the weather conditions that you are witnessing or experiencing now. As you go to the chat, you'll see other answers pop up, I'm sure. I would ask that if you see your answer has been repeated or you're about to enter something that has been entered already, I'll ask that you think of another word, but just one word a person. And I'll give you a quick minute to do this into the chat just to get us rolling. And I'm going to bounce out of the slides a moment so that I can take a look at the chat responses. Beautiful. Okay, so as the responses are continuing, I'll make a few comments. I noticed, for example, it's sunny, it's clear. These certainly seem to match up from an observational point of view. I see brisk, which is describing something about the wind. I see chilly, certainly about temperature. I must point out, as you chuckled as well, the no window. That is an important observation, an important witnessing or experiencing of what's the conditions now, because we're not always in a position to see what those conditions are. Okay, so let me go back to the slides, and I want to go from our chat entries to the following. Think about what the answer is. Okay, I asked for one word, a variety of words came through. What was this exercise all about from the standpoint of the student? It was really to understand what did they know, what could they observe, what was their moment of discovery. Very often this sort of an activity in the classroom brings forth quite a variety of answers. And not just is it a discovery process, an observational process, but it certainly provides for multiple perspectives. What are these perspectives based upon? To a large extent, the human condition, right? The overarching theme here is how do we know what's going on? It tends to be the human senses, okay? That's important. We experience the weather conditions in varying ways. We might see something or not see something if there's no window to be observed through. But it also shows that we put some sort of a context. We tend to place ourselves where we happen to be at a moment in time, and we look at those as observations of the reality that we're faced with. Okay, so these multiple perspectives are important because it might raise the question. I've had responses in the classroom where we see at the same time people have said it's chilly, it's warm, it's cool. What is it? Does that mean some of those answers are wrong? Not necessarily. Okay, so this discovery process, this observational process is important because very often when it comes to the science classroom, we're taught about the set of rules, set of regulations, if you will, that things must meet certain requirements. And it's all about making proper measurements to see what those things tell us, okay? I think it's also important for us to understand that when we use our senses, when we place ourselves in the context of an observation, we do make use of alternate senses, right? There's no window. What might you do? You might quickly get on a website and look at the conditions from a satellite image perspective. You might simply go to social media. Hey, pal, what's the conditions outside? I have no window in my office, right? We reach out, we make observations, not strictly from our human senses, but we have many ways of knowing. And I think that's an important thing that sometimes we lose in the process of science, and especially in science education and learning. Another realm that's connected here, besides making actual measurements, is understanding the relevance, right? One of the comments was, it's spring. Well, that's not strictly a weather condition, but it implies something, doesn't it? It says something about the nature of the observation, the relevance of that look at the weather condition. It's all about spring, right? That makes a big, big difference. That's quite different from last night when it was snowing quite vigorously last night here where I happen to be located. Okay, so I think these elements are important to understand, to see the context, the placement. And if we were to go further, if the conditions were not so nice, let's say the snow that I witnessed last evening, well, then my observation would be tainted to some extent by looking at the impact. Oh, it looks pretty bad out there. Bad? What's bad? Has something to do with travel conditions or walking conditions. So we start to anticipate responses when we have discovery and making observations. So I think it's important to keep the context of multiple perspectives together and understand their placement, right? These are all relevant to the study of science. So from that perspective, when we're teaching and learning science, a lot of times we talk about science as a series of processes. So let me take you to the middle of the triangle here on this particular slide. We wanted observations. Why? From a scientist's point of view, it's all about the data. Why? We want to analyze the data. We want to experiment sometimes with the data or run experiments, if it's a lab science, for example. What is ultimately all of that based upon? Well, at the bottom of the triangle, it's all about the qualitative and personal observation. What's the relevance of what I see out there to me? And it's also then, from a science perspective, all about the quantitative measurements. Is it repeatable? Is it measurable? Is it something that I can agree to with somebody else measuring the same thing? Right? And that brings us to the top of this triangle. Science is what? It's about standardization. It's about categorization. How else do we determine, well, what was it this morning? Chilly, cool, cold? Those are relative terms, and we all feel conditions differently. Or if we're wearing a coat, a jacket, a sweater, something of that nature. How do we establish thresholds and benchmarks unless we standardize and categorize how to make observations, how to make measurements, in this case, let's say, of temperature? Oh, we'll use degrees Fahrenheit. Now, 60 degrees may be warm for me and chilly for someone else, okay, especially if someone else is in Florida, for example. That's the reason we go for that standardization, categorization science. But rather than simply put that on the table and say we must standardize, categorize, why not live the experience first, right? Learning science is about learning your surroundings. It's about learning your role, your placement, your response and reaction to what's around you. So I think these are important fundamentals that allow us ultimately to get the building blocks. Because, for example, on this slide, if I'm going to create a graph, right, a horror for some students, I'm going to create a graph on the board of how the temperature is changing with time. That's a big leap for some people, especially if they're not a science major. That makes a big, big difference. And if we expect our students to construct new knowledge by making observations, and we want to go the further steps in a science course, even an introductory course in science, gets into the idea of correlating various measurements to one another, making decisions based on that data. To do what? To go even further into systems, statistical analysis, the modeling, physical modeling, computer modeling. These are major, major topics in science that are really beyond a simple reach. So the key here is not only making use of that discovery and that observation. Some might be qualitative, some is quantitative, some is subjective, some is objective. We have to put these pieces together. We don't just throw it out, right? These pieces are important to understanding and why we must use them in the teaching and learning process in science in the classroom. Okay, so from that perspective, I'd like to go one step further. If we framed the nature of discovery in terms of making observations, the relevance of those observations, that none of them are necessarily wrong observations, they each tell us something. If we want to go further and create something that talks about science and how the atmosphere itself or how the earth behaves, let's say the water cycle as on the slide, how do we get to those bigger concepts, right? How do we frame those big things if we don't understand what we're seeing, if we don't talk about the observations? It's also quite relevant because I can recall even back to my own days as a middle school student, learning about the water cycle, okay? Forget college for a moment. A middle school student presented with a water cycle. Well, when I first saw this in many, many years ago, well, I don't live next to a mountain that's snow-capped. I live near the shore, but not right at the ocean. What are these elements I'm not familiar with, right? How do I engage? How do I understand this water cycle when it doesn't reflect where I am, what I experience, right? These are elements that are important, let alone, wow, I see a lot of terms. I see sublimation, desublimation, evapotranspiration. Sounds like SAT words here. It sounds like there's a lot of things going on that feel beyond my reach. I can talk about going outside, putting on my coat for the conditions, but how do I approach the water cycle from a personal point of view, right? What's it to me situationally? I don't live near a reservoir. I don't live on the snow-capped mountain. What does that mean? Okay. From that perspective, when you're in the classroom setting, and we talked about the observations, we talked about the context. Think for a moment. Let's say we had a class that's meeting virtually like we are now, and the students in responding to that one word were from across the state of New Jersey. We would have had very, very different responses to the question, what's the conditions right now? Some areas may have reported fog. Some would talk about frost on the windshield. Some would just say it's cold. Some, oh, it's beautiful, it's sunny, it's warm. There'd be quite a bit of variation. And that's important, again, to get a handle on, because if I were to ask, oh, what part of the water cycle are you familiar with? Oh, I live by the beach, it's great. Then what about the snow melt or the snowpack? No idea, I don't live there, okay? But if we allow students then to work with one another and to storytell in the classroom, we have a different story. Oh, I know someone who lives up in Newton, up in Sussex County in New Jersey. They can talk about the fact that there's still snow on the ground. What does that mean to them? How is that responding in the water cycle today? What are the pathways of learning? If we allow the individuals to collaborate and tell stories, notice we suddenly have a fuller spectrum of what's going on. The water cycle is not one person in the midst of a schematic that shows multiple processes that have different locations, different time scales. That is not something they can kind of latch onto and say, oh, I experienced the water cycle today. That's not something we say usually, right? Oh, I experienced it was chilly this morning. I had a sweater, and then I didn't need it this afternoon. That's different, okay? It's the sum total of these experiences, these backgrounds that students bring to the table in the classroom that are important. Whether that classroom is in person, online, doesn't matter. They bring their background and experience together, and that sum total, that spectrum is created that does what? It tells us, it informs us about the science, and it also informs us about the value that students bring to the table, something that the keynote mentioned today, okay? Why is that such an important thing? The water cycle is taught around the world, science classes up and down, left and right. Why would it be so important? Well, let me go to the right-hand side of the slide here. If I'm worried about water resources, how do I know if there's a problem or how to solve a problem if I'm running low on water or if there's a fire hazard? There's got to be collaboration, which means there's going to be disagreement as well. Different contexts, different experiences. It's the summation that's important to the growth of the student to learn about science, science content, science application. And it's a segue into the idea of STEAM, right? Science, technology, education, arts, music, or you can swap out a few other things for the E and the A and the M in STEAM. These ultimately link to what? Oh, below there on the right-hand side, that looks like a series of natural disasters, from tornadoes to floods to volcanic eruptions, forest fires, and the like. These relate directly to societal issues from a policy, governance, and law perspective, okay? If I want to talk about tornadoes, let's say in a weather class, who in the classroom has experienced a tornado firsthand? Well, I've been fortunate or unfortunate, depending on how you look at it, to say I've experienced 3 directly within a few miles of me, others within tens of miles. My experience with tornadoes is limited, but I've been there for some. Has every single one of my students been near one? Probably not, at least in this part of the country. What if I'm talking to students in Oklahoma? They've lived with them all their lives, okay? What about a hurricane? What about a superstorm, Sandy, or a northeaster, a snowstorm? Well, if I start talking to the students and they start sharing their stories of how they encountered a snowstorm, a tornado, a hurricane, something of that nature, I will start getting a broader perspective of what that event was all about, how it reflects science, how it's studied, how meaningful it is in all the aspects of what we look at from science perspective. I can show videos of impressive tornadoes, hurricanes, fires, floods. Well, it's eye candy, ultimately. It's a show and tell to say, well, here's what happened. How do I make this personal? How do I make this something that they can truly engage upon and say, well, I've never lived through a tornado. What is that like? Let me show you something. Let me have you hear a story from someone who has experienced a tornado or two. Much more powerful. Okay. I do take pause at this moment. Karen Harris had told me to promise I would share with you the session objectives, but I wanted us to go through those exercises to get to this point, to be able to share this in a broader sense, to say, how do we develop our student engagement? Well, that one word activity, right? It's a very simple do now sort of activity. It's connecting to the students and their senses and how they learn about themselves and about the world. How do we build that? How do we construct new knowledge or expand that knowledge base? Well, we need individually their value individually. We need that collectively to tell stories, to put together, so that instead of saying, well, I see something that looks like the trunk of a tree. Oh, I see something that looks like a tail. I see something that looks like a hose. What do you know? We put the pieces together, it's an elephant, right? That's one of the old cartoons that shows up that says, if we have a bunch of people looking at the same thing, we'll get very different answers. If we put those answers together, we'll start to construct something that actually is meaningful. Okay, so that's the nature of this. So we're trying to create and incorporate pathways that can access student value, rely upon their experience and background, their knowledge, because that makes it easier to connect then from the STEAM, the STEM, and the real world. If we're talking about natural hazards, if we're talking about water resources, it's through that storytelling and STEAM approach that we make it relevant, right? That's the intent behind what we do here. So as I said, I promised Karen I would share with you the session objectives. This is related to what summary of the session that shows up online, and we'll get to the others. Don't worry about that. I just wanted to share that with you. We're making quick strides. We only have so much time today, so I wanted to go through to this point as quick as I could. We talked about the relevance of things to reveal various findings in science to the students and how things work, how we study them. It offers them revelations as to why this is important. Why do they have to take a science class at all, for example? But then we also are faced with the more difficult topics. Let's say the electromagnetic spectrum. The answer from students, the what? What are you talking about? If they're on their phone, they're probably typing WT, something like that. The electromagnetic spectrum, what is it? I see on this picture, it looks like a bunch of squiggly lines, and I see some pictures underneath. How do I relate that to me? A difficult concept. Electromagnetic spectrum is usually brought forth as types of energy, various wavelengths, different amounts of energy or power behind them. And here's some numbers, and the wavelength is so small you can't see it. Well, what does that do for me? I can see clouds, I can see snow, I can see the rain in front of me. How do I relate to something that I just cannot see? Okay. Well, sure, there are segues to talk about, well, skin cancer, ultraviolet radiation, don't be out in the sun too long. I can see the after effects. I cannot see those effects here and now, unless I have a measuring device. Okay. Oh, a microwave. We use microwaves. Okay, so the sun's cooking us? That doesn't match expectations. Oh, but there's x-rays in here. Oh, wait a minute, x-rays. They look inside the human body and the bones. Ooh, the structure's inside. I can somewhat relate to x-rays. They're looking through me. Okay, so I must understand there must be some differences. I use a microwave at home and I'm not injured. If I get too many x-rays, that's bad for me. If I stay out in the sun too long, that's bad for me. There's some connections that can be made. And there's also the use of cell phones. Oh, that's microwave communication. Wait a minute, that's microwaves too? What would students react? How can they respond to these sorts of things without some other physical manifestation? So for example, I've used different approaches over the years, but one that tends to resonate fairly well with students is being either in a wave pool or at the beach. The spectrum is spoken with regard to wavelengths and amounts of energy. The shorter the wavelength, the more powerful. The longer the wavelength, the less powerful. Well, what if I'm at the beach? What if I'm in the water? What if I'm standing in the water and there are waves approaching me? But they're only about so high. They're not over my head. I'm not too frightened. Those waves come by and I feel the force, right? The energy they possess exhibits a force, and I notice, I get something from that. Well, the more frequent those waves, the more force I feel, the harder it is for me to stand up against those waves, even if they're only up to my chest. That's different from saying, well, I only see one wave every so often, but that wave is twice my height. Okay. It's in these sorts of approaches that we can link some physical manifestation of the nature of wave theory. That's something in electromagnetic spectrum. We can link something about wave theory into something they can relate to. Okay. Another example I've used over time is the idea of karate and other motions. When you talk about the proper emotions and to throw a punch or land a punch or something of that nature, it becomes important to understand the amount of power, the strength, the energy behind these things, and what it means to have something striking repeatedly or less often, and how tall or large this wave might be. Okay, so getting to those harder issues like the electromagnetic spectrum, you still have to come back to something that can be connected to, something that can grab onto the tangible to use as an analog to understand the phenomenon in question. Well, that's more of a mathematical thing and a physical thing. What about something like the land of the midnight sun? Okay, I've taught that for quite a few years to students in the classroom, and many of them, they hear about it, they read about the term, they read it in the book, and they say, yeah, well, okay, so there's a midnight sun. The sun never sets. But have you shown them a picture to see what it looks like where the sun gets closer and closer to setting and never sets? Do they understand, unless you have them read something from people living in Northern Europe about the sun setting at 10 or 11 o'clock at night and rising at 3 in the morning? The need for curtains in hotel rooms to block out the sun because people don't want only 4 or 5 hours of sleep, they'd like to sleep longer. What if we bring that storytelling then from elsewhere, not just from in the classroom, but from others, right? Where do we bring in the culture from other areas that tells us more about the planet, about science, about how things work, how they relate to people? Okay. That's one example. Another is the idea of the lower right here. I have a picture of a fog screen. For many locations in South America, for example, other parts of the world as well, fog water is collected by massive screens. It's their only source of potable water. There's no well to go to. There's no infrastructure that provides clean tap water. They have to collect water. Okay, that's a different scenario for them to understand. And without having storytelling per se, how will they know that? How will they be able to understand that aspect of it? So these cultural connections are very important, and it allows the idea of including a wide variety of diversity, meaning diversity of experience, and peoples from different parts of the country or different parts of the world. So with that, I'd like to take a break here in the following manner. I'd like to go into breakout groups. And I think, Natalia, you had mentioned that you'll set that up once we get rolling here. I'd like to ask that in your group, if you can quickly identify what you'd say is a common science item or topic that you struggled with as a student or that your students struggle with, and come up with a few key reasons why they struggle with that concept or with that item. Okay. I'd ask that you pick one member of the group to report out. I'll actually give you a few minutes this time to kind of reason it out, talk amongst yourselves, and then I'll ask for the breakout group to come forward with some responses.
Okay, so I was with breakout room 2, and I know we had a little bit of people with permission issues, but for those of us who did get to speak, it seemed to be a combination of either a specific content or it was dealing with engagement, especially this time of year when it starts to get nice out, and that begins to be more of a struggle, especially with the online components that are still kind of occurring in a lot of public schools, just keeping them engaged. From my personal experience, as well as a couple others, it was the chemistry, especially once we moved online. I used to be a biology teacher through K through 12 education, and when we switched to virtual, I was like, how in the French toast am I going to teach these children organic chemistry when they have zero background about any chemistry for an entire marking period? So just kind of finding ways that we're able to engage them and make things kind of realistic to them in the world by just using things around them, like in their kitchen or at the gas station or whatever it was, and just kind of taking those things and trying to make it more engaging.
How are you guys?
Hi, Kristen.
So in our group, we kind of discussed, we had somebody who was more on the computer side, I'm on the bio side. But overall, we kind of both agreed. I threw out a topic of spectrophotometry, which was related to what you were talking about. And when we went into the full online environment for bio, and same thing with the computer side, there was like a lack of really good resources to show them how to do the technique, because they couldn't do that particular lab anymore hands-on for us, and our hands-on students, when they're on campus, thank God we're back, but really get a good grasp of it. So it's just kind of the lack of resources that are out there for those complex topics that you can't purchase a spec and give it to each one of your students and say, okay, do spectrophotometry in your house. So it's that lack of the online resources that are available.
I was fortunate to join one of the breakout groups, and common issues that came up were chemistry and physics. How surprising. Not really, right? The example I presented was about electromagnetic spectrum. When it comes to rotational components from a chemistry point of view, even a physics point of view, how do you get those concepts across? What about molecular linkage, right? What about bonding between among molecules and things of that nature? I'll just share as an example, when we get to talk about water in the classroom from an earth science or atmospheric science point of view, students haven't thought before about the fact if you pour water from a bottle into a cup, water flows because it's connected. Right? It's not molecule by molecule. Water molecules tend to link into chains. And if I was trying to teach that concept, believe it or not, even at the college level, if I had the time and I asked them to put a bunch of paper clips together and then start at the top of the near the ceiling and start letting them go one by one, they would see the flow of paper clips to replicate what goes on with water molecules, right? There's a wide variety of presentations that are possible because we know, and that's why I have this slide up here, we know they're not subject matter experts. Well, and I'll say this plain and clear, right? I've been in academia and I've studied my discipline, atmospheric science, for 30, 40 years of my life. It doesn't mean that I know everything, obviously. None of us do. We're not all subject matter experts on every element, and that revelation is also important for students to see. And then their experiences can be brought in. I know it leads a little bit of angst in the classroom setting because there are many situations with topics that are well beyond the scope of students' experiences where we have to latch them in somehow. And then if we see a proper analogy, take it and run with it. We really do. I can say after how many years of teaching the intro meteorology course, I don't think I've ever taught the subject matter exactly the same anytime ever. Have I always taught about the fundamentals? Absolutely. Have I ever taught it the same way in every single classroom? No. It always goes back to the background experience of the audience that's there, the participants, right? We don't want spectators or the audience, we want participants. So the importance of collaboration there is relevant because sometimes you get the students start thinking conceptually and say, well, is it like this? And those are great launch points. That diversity multiplies the inputs from the others, right? It makes the information more accessible. It allows the storytelling to come in. It allows the sharing to continue, as opposed to some students will start shrinking back. Well, this is, wow, I understood about temperature, but this whatever spectrum thing that was he called, I need to step aside. I'll watch, I'll study what I need to know for the exam, right? That's what we're trying to avoid. We don't want departure or pulling away. We want staying in there. Even if they're not fully comfortable, there's a lifeline, okay? And again, I think that's where the knowledge is important if we provide the proper context. This offers us those opportunities with learner types, the types of pedagogy that we apply in the classroom. And if we can always kind of take that step back to the holistic view, right, that conceptualization, even as in-depth as I would go in certain topics about the atmosphere and how it behaves, ozone or something of that nature, I would still always have to step back and posit it in the sense of the bigger picture and the world they live in, right? We cannot lose sight of that. That still has to be brought back in repeatedly, so they know that they haven't lost touch with where the land is, right? They're not out with the current offshore, no hope of getting to shore. They can't see the shore anymore. We don't let them lose sight of that along the way. Okay, so that's some important points I think would come from the breakouts. Obviously, it's not that we have all the answers today. It's we understand there are significant issues approaching certain topics, and that's really the key here. So this is good because since I won't give you 2 minutes, I'll give you 1 minute for this particular activity. I'd like you to use the chat feature again. And we haven't talked too much about the use of technology. But in the classroom, right, I can go back many years and say from the chalkboard to the whiteboard to overhead transparencies and the like, to the modern day virtual reality goggles, clickers, things of that sort in the classroom. What type of technology, pick one and share it in the chat. What key technology do you use? And when you use that, why are you using it, right? What's the pedagogy? If you could just share that in the chat. Okay, so I see a few things coming in, the calculator, structuring the course, recording of lectures, mirror of the iPad, so you can see the construction of knowledge, right? That often happens, the use of Blackboard. So there's usually technology as a resource, right? It's a tool, and that's typically what we use it for. And I think what we have to keep in mind is that we want to make sure that we're not just using it for the sake of using technology, and keep those responses coming in. They're good. And I want to jump back to the slide set from this perspective. Okay. As your responses are coming in, I would just say that the use of technology, the question we always have to ask, and we very often, at least me as a scientist, very often I'll say, well, of course I'm using this technology because I want the students to be able to do the following. I don't always go back and say, well, is this appropriate? Is it facilitating what I wanted to know, or is it an impediment? I do have to ask, is it equitable, bearable, viable? Is this something that actually students can get a hold of? I recall in the keynote today, she mentioned about the use of the cell phone by students. You cannot do everything on a cell phone if you're trying to visualize, can you? Right? How equitable is that? How bearable or viable is that from a learning perspective for the student to best understand what you're trying to share, right? And so very often I found myself doing this much later in my career. I should have done it sooner. I didn't have anyone tell me. Later in my career, I said, wait a minute, we assess everything under the sun. Why are we not assessing the use of our technology in a specific context in the classroom, a specific lesson, or a specific piece of a lecture, okay, or a lab for that matter, right? So these connections are important because it's about access and inclusion for the students. If we have them and we're bringing them along and then suddenly we throw technology at them that they have to spend 5 hours outside the classroom to figure out, then we may have just undone the good that we've done with them, right? That's always a concern. I think that's something we have to keep in mind. So minding the time, I will just reach out in the following sense. Thank you, Natalia, for letting me know the time remaining. I go back to the end sense of what we're trying to accomplish here. It's like the U.S. Department of Agriculture. They have their plate of what's a proper diet. Well, are we feeding a proper diet to our students in science? Are we helping them teach them and helping them learn? Because science is not simple. Other topics aren't either, right? Philosophy is not simple to teach. If we can keep the engagement and relevance, okay, create a zone that's all about engagement and relevance. If we can keep that up throughout the term, that's important. Throughout every class, that's a must. Take that trip into the engagement relevant zone, we'll be able to add the other benefits, the diversity, the equity, and the inclusion, accessibility, the cultural manifestations. Those things we can do because we'll have relied upon the storytelling, the framing, bringing things forward from qualitative to quantitative. I always say there will be concepts and hidden meanings no matter how hard we try, but also hidden figures. And if you know the movie, that's how we get those stories, don't we? The path to the moon wasn't simply, here we are, with the people who were involved along the way, besides the astronauts, right? These are very powerful connotations that can come into a classroom setting, whether it's science or any other topic, to engage the students and get them to collaborate and see how it matches their value that they bring to the room, okay? I like to tell others that I've worked with over the years, if you could say I've mentored some people over the years, I say, well, anybody can cook and anyone can learn how to cook, but we are intended to be the chefs, right? We have to create the masterpiece, so to speak, that reaches out to everyone, okay? And while I can cook to a certain extent, I'm no chef, right? Always learning, always being open, that's key. That's what has to happen, okay? So I will close this show just because I know I want us to get out in the open here, especially if we have some questions or not.
Okay, we have a questions. Will we have Paul contact information from this session?
Okay.
Well, Paul, you can share your contact information in chat if you wish. Also, next question, how can we keep the curious students ahead while maintaining students falling behind, stay connected in online environment? Oh, we have another couple hours for that one.
True. And I'll give the short answer, which is for those who naturally are getting it, so to speak, and advancing along, they become perfect nodes to work with the others, right? They become natural leaders within a group. And what I love about that is over the years teaching a course for non-science majors about the weather, I've had history majors, English majors, and I could go on for others, who actually did as good, if not a better job than a rising meteorology student in that class, because they brought it back to themselves, not strictly about themselves and the science as a major would.
Yeah, I think I also can add, try to differentiate your instructions. You know, students are different, and we can be flexible in assignments and in assessments. It's very useful if you have a variety of assignments that you can address everybody's needs. Well, I think
no, thank you, Natalia. The other thing you just the other thing you made me realize that I should have mentioned along the way is language, right? Scientists have a language. And when you get taught science strictly, it's very remote and a great departure from how we communicate. And, in a science class, if you want to put up the temperature on the board and say it's 20 degrees and people look at you, say, it's not that cold outside. You tell them it's Celsius, not Fahrenheit. You've just begun a conversation about language and translation that they never thought of.
Thank you so much, everyone. It was great to spend some time with you. Bye, all.
Thanks, all.